Yes, it's taking some time to start the recording, that's why. Okay, yeah. So as you see, this is my Google Drive share, which you have access to, mainly this drive. You have access for the foundations of machine learning. I'll be sharing the link. And I added this additional folder, which is cheat sheets. The cheat sheets folder. We will discuss some of the cheat sheets from within this folder, and you can go ahead and just read the details from each of the cheat sheets that I will be presenting. But before that, the notebook last week, I added this notebook. So let me open the notebook. And by the way, this CO means collaborator. So this notebook from my Google Drive is opening in a Google collaborator lab. So this is the notebook, the Jupyter notebook that we were using in the last two classes, and I will be continuing to use this. And if you remember last week, I was having issues with my personal machine. So this is a very good practical scenario where you would run into issues running a machine learning training or whatever processing on your machine while doing something else. I'm using my machine for doing the presentation, mainly like just the Teams detail. So my machine was busy. So I told you that I would be offloading the machine learning processing onto a Google Collaborator. I was doing the code execution locally using Visual Studio. So this is the Visual Studio. I mean the VS Code or Visual Studio code that I was using to execute my code. Instead of doing that, today we will be using the Google Collaborator, one of the 3 cloud machine learning service providers. Google Collaborator is one. The second one is the GitHub Code Space, which is provided by Microsoft. The third one is Anaconda Nucleus. So these are the 3 cloud-based machine learning compute providers, cloud-based compute providers, and I believe Kaggle is another compute provider. And I haven't checked Amazon's compute provision, but I think just Amazon might also have the same service. In any case, you can use any of your environment. So to remind you about this Google Collaborator, I used this on our first class as a showcase, and now we will continue. The way I opened this Google Collaborator is by going into the notebooks and double click this IPyYNB, which is an extension of a Jupyter notebook. So this notebook got open, and as a result of that, you have here. But when this notebook opens, there is no compute yet connected. So just we can connect the compute. I'm going to connect. And what this does is it is providing me with a compute environment having the following details, right? The following details. The system RAM is 12.7 GB and the disk space is 107 GB. So I have this much area, I mean RAM and storage, so I can use this device. And the amazing part is it is free. So the only thing that I'm expected to have is the internet connection and a browser. That's it. Then I can use. So last week we discussed about in the last 2 weeks we discussed about two important packages, which is one is NumPy, which is a multi-dimensional array object, a multi-dimensional array or object processing package having multiple capabilities that it provides to you. And also we discussed about pandas. Now, pandas is for creating data frames and processing data within data frames in a tabular format. NumPy is for creating two or more dimensional arrays and to transform raw data into desired format, to clean transformed data into a certain way. So Matlab is the third important library, which is used for plotting your different types of graphs. So today we will briefly see Matlab, and this introductory part will be concluded by looking at different capabilities. And as you can see, we have our machine started, so we can execute this without any issue. So since we have gone all the way, and I'm going to start with Matlab. So Matlab is a Python library that is specifically designed for the development of graphs, charts, etc., in order to provide interactive data visualization. So in machine learning, data visualization your data, it gives you an opportunity to see the different attributes of your data depending upon the type of graph that you can use. So you can plot your data in a certain way. Simple example is if you have a two-dimensional data having the X and Y values, you can simply just draw like the coordinates on a plane and see whether or not there is a linear relationship between the points. So that's one way. Another is it helps you to draw different types of graphs, histogram, scatter graphs, line graph, pie chart, all kinds of charts. So just we will take one chart at a time. Simple example. So the way you initialize pandas, I mean the Matlab is like this. You simply import the Matlab library as pyplot as plot. So as I told you last time, these kind of names are short representations of the entire library. So from this library, pyplot is represented with an alias, just as a simplified name. You can say you could say just PL, but just to make it easier for you to remember wherever you are, PLT is the most common naming for the Matlab package. Now, so the only thing that you are expected to call from this library is plot. But when you make a call to the plot method of this pyplot, you would have to pass values. And look at this. You have 1, 2, 3, 4. When you do this, what you're doing is you are saying plot this value for me, but use the default index, and I will show you. And not only just you should provide the data to be plotted, but also you have to say, show my graph, show the graph. Let me clean, since I have run the graphs, let me clean everything that I have done here. For cleaning, you go to in the runtime and you can restart and clean the. Let me quickly check. I think there is a shortcut. Control Shift. I think Shift. Runtime. Restart. Okay. Okay, let's see. View show focus. There is a way to clean. Unfortunately, I forgot it. Okay, yeah. So that was it. So Shift the clean method is Shift plus Control plus Enter. So this is to clean the outputs. So yeah, I cleaned all the graphs that were already created by simply just running Shift Alt Shift Control Delete. Now let's run this. Said. Yeah, running this cell. So this cell is run, and now so when we run this cell, what happens is we provide the data in to the graphing method, and then just this data will be plotted. So we are doing this. So look, now 1 with 0, 1.5 with 0.5, it goes like this. And we have these numbers, 1, 2, 3, 4. So 1, 2, 3, 4. At 4, we have 3. And if you see the points, then you can see this 0 was implicitly mapped. So this implicit x-axis values from 0 to n-1, where n is the length of the list. So the length of the list is 1, 2, 3, 4. 4 minus 1 is 3. So up to 3, it will go 0 for x, and the value that's provided by as input is considered as a y value, and the x value will be by default taken as 0, from 0 all the way to n-1, where n is a number of elements or the length of the elements. So plotting is like this. And range, by the way, is, let me quickly add one code so that we are going to use range multiple times. Range gives us print range. Okay. print x for x in range. Range basically just gives you 0 to 0 to and the given value minus 1, or 5 minus 1 is 4 elements. Then just this graph will plot as follows. So x is a value that you get x is a value that you get from within this range. If the start point is not provided, then just it starts from 0, and that's the definition. I'm hovering on it. When I hover on it, it gives the definition of it returns an object that produces a sequence of integers. The start is inclusive to stop, which is 5 exclusive. And if the value, the initial value, is not given, then just what's the value that the single value will be the stop number. So the x is like this. So we start from 0 to 4, but what we're doing is we are plotting the value of x where the value of y is x1 square for x in x. So this is what it is. So x in x. So this graph did the following. If we increase this number to let's say 6, this becomes all the way to 6, and this becomes 236. And then just you can see here, x no 5, sorry, 6. The last number is not included, 5, and then 25, because this number is the last number. So what this means is start from 0 and end at 6. It's like this. So it starts from 0 and ends at 5 because 6 is excluded. The same with or without 0. 0 is the default start point. The second the other type of plot is we can use NumPy to specify the values for both axes with greater precision. Now, x is a range, and just a range goes like this. And let's see what this has. And x is created. Okay, so because NumPy, we didn't add NumPy. You see, NP is not defined because we didn't initialize. So what we should be doing is we have to import NumPy as NP. Then this error will go away, and it's done. But what we should be doing is for x1 in x, print x1. So this is the value that we will be getting. You see how detailed it is, the precision. So what this it's continuously printing and just so this number, this range, it starts from 0 and ends at 5. Excluding, including 5 in the case of our range, and then it is incrementing by 0.01. Here it starts at 0 because the start point, and 0.1, 0.2, 0.3, and it goes all the way to 0.1. I mean 0.01 because the increment is 0.01, and this array gets printed all the way to the last number, which is 5. Right? Which is 5. And 4.99. The last number is not included here. Okay. So what we did is I'm going to comment this so that it stops. I'm going to comment this. And so now, so that we can collapse the thing. And what this guy doing is generating those numbers, the numbers that I showed you. And the plotting is for each of those numbers, we are squaring a number. X1 in X means X is the range, like those numbers. For each of those numbers that starts from 0 and increments by 0.01 all the way up to 5, we are generating X and the corresponding X square. So this is a quadratic graph between 0 and 5. The last point excluded 0 and 5. So this is the quadratic formula. I mean the quadratic graph between these two values. So plot, just matplot. Matplot enables you to plot this, and you can do so many other things and the plotting. But just remember how you should be. We are generating numbers so that you can see the plots. We are now plotting 5 different graphs. I mean 3 different graphs. The first graph is directly X for each X1 that is generated. This is 0 to 4, and X, the second graph is a quadratic X square, which means X1 for each X1 in X. By the way, this is a looping in Python. This is looping, and this is again X cube for each X, X1 times X1 times X1, X1 cube for each X1 in X. So we drew. And remember, like, just look at this. We didn't provide color. Whenever there is no provided color, Matplot will automatically pick up different colors for different graphs that we create. In addition to plotting, now just we are plotting multiple plots. One plot, which is x2, each x1 from, and another plotting, 3 plots. Or we can combine all of them as inputs provided as x1 with this, x with this, x with this. So the plotting understands this also, and the graph will look exactly the same. These two graphs are exactly the same, but the only difference between the two is this is plotted individually, but this is plotted at once. Different colors are used for different lines. And we can also add grid, like, remember, if we want grid here, we can add grid. Let's go back to the first graph. It was kind of confusing which number is associated with which one. So here I can add grid, and then the grid will come. So you see, 0 is 0 with 1, 1 with 2, 2 with 3, and 3 with 4. So this is how the grid. So just simply adding this line creates that the entire grid that we have, and we can add grid for every line we have, every graph we have so far. So here, running this for the same, then just we have X in x into x1 times 2, x1 times 4. So these are like basically just the slope is a little changed. The slope is getting increased. The slope of this one was 1, this is 2, and this is 4. So because of the slope. So we added the grid, and also just we labeled the axis. The x-axis are set to new limits. We said start from -1. Now, so sorry, that was different. So this is by default start from 0, but here we can start from -1, and then just the graph will look like the following. So we said start from -1 because we said plot axis -1, 5, -1 to 10. So -1 to 5, and then -1 to 10, -1 to 10, and it is set. So -1 in both cases is initial, and 10 or 5 are the 4 numbers. And also just we can limit individually. The x limit is here, the y limit is here, which is a different way of saying this axis limit. When you do axis limit, the first 2 values will be taken for x-axis. The second pairs will be taken for y-axis. Instead of doing that, to avoid confusion, you can add axis, and then just the same graph gets generated for you. Now, you can also add x-axis, y-axis labels, so that you can distinguish what each side is. And here you go. So the y-axis is here, the x-axis, depending on the order and the label, x label, y label. So we are labeling the axis as x-axis, y-axis. And you can also add title. So not only like you see the title, this title came from this title, this title. Now we have x-axis, y-axis, and title. After putting your data on a graph, you have to have some description. And we can also add labels or yeah, so we can also distinguish the different what each graph is for, which means a key. Linear is the line, square is for the quadratic, and cube is for the cubic graph. And this is a polynomial graph. So x into x, x into x squared, x into x cube are plotted and for these same numbers for this range. And we say linear, square, cube, they came right here. This is a default position unless you specify. And the x-axis, y-axis, we already discussed, said that, and the polynomial graph, which is the title. And then just this is the legend. Add legend means here, and you can say just the position of the legend. Like if you hover on it, the legend, there are arguments, or you can provide position here. The other is you can add markers. You can add markers in your graph. So we are plotting x and y here. So now these are the markers, and the points that you have bold. Okay, BO means a bold graph. We provided this, and we are plotting, and then we are providing these values with the font size. And if I increase the font size, you will see the coordinates will increase. Let's say 13, from 10 to 13. Then these numbers got increased. So x coordinate, y coordinate, right? The texts are x coordinate, y coordinate. They are presented just like this, and then their font size is this. So we are defining how the text should, the plot text should look like, and then just showing. X coordinate is x of I. We are taking the values from these two arrays, x and y. For I in range, lengths of x, for these lengths, we are iterating through and then, plotting those values here, and finally showing the plot. That show should be called at the end. And again, here we can plot, we can save the plotting. This is save fig. So this is a method that we add. Everything is there. Not only just does this show, but also it saves to the current working directory, or you can provide a directory where you want to save your graph. So just this save method is helps you to save everything else we have already said. And like Matplotlib enables you to plot scatter plots, histograms, bar graphs, and pie charts. And the reason why we are spending this much time on graphing is very important, because we will be using this wherever we want to see, we want to visualize our graphs or our data on different types of graphs that are appropriate for the type of data that we are dealing with. Now we are generating a random number. So from NumPy, we are generating a random number, which is random dimension 10, 100 by 100, two-dimensional array of Gaussian distribution. And then just we want to plot a histogram for y. Let's do that. And it's generating, then just here you go. So you have these numbers. They are generated random dimension or a Gaussian distribution. And if you want what this data looks like, we can see like this. This is how the data looks like. This random distribution looks like this. As you can see, I'm assuming that just you have taken statistics, or like just definitely you take statistics. If you see this graph, this is a normal distribution. This looks like a normal distribution. So the reason the reason is because we chose a random but random normal distribution, and random normal distribution of this. So that's the reason why. And again, just we can take the default bin value of histogram with 10. Then just we have this kind of graph, right? This kind of graph. So a histogram and the values are divided into bins of 10, in bins of 10. And another type of chart that we have is a bar chart. Here we have a bar chart. This is X and Y. X gives you the markings 1, 2, the middle markings of the bar graph, and Y gives you the height of the bar graph. This is 1, and this is 4, and this is 9, right? So the mark, just this one, the midpoint of the lower face of the every bar, and the value Y, or the Y array contains the height. And there is a one-to-one mapping between the numbers, the pair of numbers, one from X, another from Y. And so we can continue doing this, but just that you can associate colors and styling for your graph. And let's see just this interesting graph. I will draw the graph so that you can see, and these different colors are given, but as you can see, the default values are used as the lower mid 0, 1, 2, 3, which are not related to the numbers, but they are default values. But yet we can associate the values, the keys of the dictionary. This is a dictionary, which is our data containing A25, B20, A, B, C, and D are the keys, and then the individual numbers are the values. So by simply taking the keys as the X ticks, then we can change the graph to show with ABC instead of just 0, 1, 2, 3, 4. The default value, we are using the data itself as the x-axis label. And remember, here we didn't include the x-axis and the y-axis, but we can add plot dot x label, and then we can say x-axis, just to add the x-axis. X-axis is added, but there is no y-axis because I didn't add. Plot y label, then I can give it y-axis or whatever. I could say height, then the height value will show as we saw earlier. And another type of chart is pie chart, and this is how the pie chart comes out. So the x-axis are the individual values, as you can see, 40-25, the proportion, and then the labels map to one, like by position. 40 for bikes, 20 for cars, and 5 for buses. Cars, 20, 5 bus, and 40 bikes. So that's how you would do. And a scatter plot is, now we have X and Y randomly generating 1,000 numbers each, and just both X and Y are plotted as coordinates on this plane. Then just this is a scatter plot. And another point is you can add styling. So why? So it allows to choose custom color for plots. Now we are starting from 1 to 3, 1 to 3, and for each value. But the y value, the first one is y to y. Y to y means this is the first value. The second value is y plus 5. It adds plus 5. For 1, we have 6. It goes like that. And the other one is y plus 10. So above 10, it goes. Just all of them are kind of identical, but a little different by the amount of constant that we add. And it automatically picked the colors, but we can choose different color for each of these. And the coloring code are B for blue, C for cyan, G for green, K for black, K, okay? M for magenta, and R for red, W for white, and Y for yellow. So here we are using a color. So here we go. Matplot allows different lines style for plots, and solid line, dashed. Well, so sorry, we are simply just, if we want dashed, we have to use 2 dash. If we want solid, we have to use just 1 dash, or like For example, for the first one, if I simply use one dash, you will see one of the lines to be solid. These lines to be solid. But since we used two dash, the first line becomes a broken line. And the other line is like dash and then dot, dash and dot, which corresponds to this dash dot. So, and you can play with this. So this is what I wanted to cover for 2 days in our today's class. So Matplot is a very important tool that enables us to visualize our data in different ways. So we will be using this. So of all the libraries that we will frequently use in machine learning, the Python libraries are NumPy, Panda, and Matplot are the three important libraries that we will continuously be using. And this summary or introductory part is to enable you to utilize or to get familiarize yourself with these libraries. And if there is any question, you can ask on the line. The definition of x is equal to range 5 provides integers, but the plot is in float. Okay, yeah, so this is a very good question. Okay, so okay, there is another question which I suggest. Yeah, any project related stuff, please work with your university coordinator. Please work with your university coordinators. Any project related stuff. I cannot handle everybody's request. So the best way is you reaching out to your project, your university coordinator, and then you will be added to the appropriate group and can be yeah, is so Johannes, if you have a question, let me let you. Now you can speak. You can unmute yourself and speak. Johannes Stot. Did you have a question? Okay, so I see a hand raised. So if you didn't intend to raise your hand, please lower it. Click the same hand button and then it will lower it for you. Okay. Okay, so this covers. Now we will go to the next phase, which is introducing all of you to the machine learning process. Johannes, please lower your hand if you don't have question. I will let you ask a question one more time. You can unmute yourself and speak. Oh, can you hear me, by the way? Okay, good. I got the answer. Enough. I got the answer from one person. Yeah. Yeah. Yeah, I heard that I can see that you can hear me enough. So there was another question. Can we draw 3D graph using Matplot? Yes, you can draw 3D plot using Matplot. You can see how you could do that. Yeah, so I will leave that additional experiment for you. But the important thing is Matplot is the most useful library that we will be using in our data processing, data visualization phases. Okay, okay, great. Now let's move on. Let me take, unfortunately, okay, let's see. Yeah. Okay. So I'm going back to my OneDrive. In OneDrive, I mentioned earlier that I'm going to talk to you about important resources here that I added, which are cheat sheets, And these cheat sheets are important. Can anyone tell me what cheat sheet in Amharic means? You are very familiar with it. What does cheat sheet mean? What does cheat sheet mean? Okay, so there was exactly somebody answered that. Cheat sheet means አጤሬራ ማለት ነው። አጤሬራ ማለት ነው። Cheat sheet. For in most cases, you use አጤሬራ to remind to hold on onto an idea, but just the deeper detail is only in your book, in your book, but you are extracting very important information for your use. So we will be using okay, yeah. Good. So I have these three aterera for you. Very important aterera. And then just I will go through them, and they are going to be very important for to simplify our discussion. And you can download, but I have them locally loaded. This is one, and give me one moment. Let me add the other one. Okay. So I have two additional atereras. Okay. Okay. So now the first aterera that I'm going to show you is just a collection of atereras. It is of 191 pages. It doesn't look like an aterera, right? Because it has got so many pages. But the individual, the detail is aterera. So let's start from the first one. This is a data science lifecycle. Data science lifecycle. If you remember our discussion last time, so this is from the ML and look at the title, the ML and data science lifecycle cheat sheets. So there are multiple cheat sheets in this collection, which is 191 page. In most cases, a single cheat sheet may span 2 or 3 pages in most cases, and very frequently a cheat sheet is only 1 page long. For example, this one is a 1 page long cheat sheet. Just a 1 page long cheat sheet. And then this basically summarizes one thing, which is the data science lifecycle. It starts from business understanding, and then just data mining, data cleaning, data exploration, feature engineering, and predictive modeling, data visualization. So this is the cycle. So this cycle summarizes, and each detail is added. Ask. So in business understanding, it says ask relevant questions, define objectives for the problem that needs to be tackled. The second step is gather and scrap the data necessary for the project. So this is data mining, or basically data collection, not mining, data collection. It's this kind of misnomer. And the third step is data cleaning, which is the data preparation step. Fix inconsistencies within the data, handle the missing values, and then just go on. The fourth is data exploration. Data exploration is, for example, using Matplotlib, visualizing the data, explore, see what the data looks like. Then form hypothesis about your defined problem by visually analyzing the data. So this is visual. Exploring the data means visually analyzing your data. And the fifth step is feature engineering. Feature engineering is nothing but like creating new features that didn't already exist in your data. So select important features and construct more meaningful ones using the raw data that you have. And the sixth step is predictive modeling. So this is a training step. So you train a machine learning model, evaluate their performance, and use make predictions. And finally, data visualization. Then communicate findings with key stakeholders using plots and interactive visualization. Mainly, this seventh step could be a different step. It could be like deploying your model to a production environment where it can be used by one or more client applications. So in any case, this gives you just a highlight. Now, this is one of the cheat sheets that summarizes probably just a chapter size, one chapter size content detailed in one page. The next is these are, by the way, just it is rotated. So if you are using PDF, you can use Control Shift minus to rotate it to the left, or Control Shift plus Control plus Shift plus to rotate it. Control plus Shift plus rotates it like this. Control plus Shift plus minus rotates it like this. So these are the list of cheat sheets that you have. These are all the cheat sheets. What is data science? Types of data, main types of problems, probability overview, descriptive. These are important details. Descriptive statistics, data cleaning, feature engineering, and all these are individual cheat sheets. And a cheat sheet for business science, a cheat sheet for Jupyter Notebook, like Python for data science, like Data Quest for Python basics, Python intermediate, NumPy, Pandas. Like if we go to page 18, then just you will see the NumPy details, the details that we summarized. So you have all these cheat sheets. Let's go to the most closest one. So this is a data science cheat sheet. And now you see how this at ERERA is helpful. What is data science? Data science is a multidisciplinary field that brings together concepts from computer science, statistics, machine learning, and data analysis to understand and extract insights from the ever-increasing amount of data. Then two paradigms of data research. One is hypothesis-driven, the other is data-driven. The heart of data science is to always ask questions, always be curious about the world. What can be learned from this data? what actions can we take once we find whether it is we are looking for. So these are the kind of details that you would see. And about types of data, this is we have structured data, unstructured data, or quantitative data, categorical data, or a big data. So these are the different types of data, like depending upon the nature, and the corresponding details are briefly described. The other is a probability overview, because now main types of problems: classification or regression. These are the main types of problems. The classification is assessing, assigning something to a discrete set of possibly, say, example, as spam or non-spam, like email classification. You classify email as spam or non-spam email, or Democrat or Republican, or in Ethiopian case, Bilsegna or some other party. That's just what it is in voting system, or blood type A, B, AB, or O. So this is a type of classification. In machine learning, you would be doing this kind of classification. The other one is regression. Regression is predicting a numerical value. Example, someone's income, next year GDP. So regression is predicting a continuous value, a continuous numerical value, a value that can take any number. So these are the types of problem. Imagine how useful this is. Then in data science, in machine learning, the foundation of data science and machine learning is probability, and mainly statistics. And statistics provides you like just a way to understand a probability, and also probability depends on some descriptive statistics, right? So you learn about experiments, about sample space, event, or probability of an outcome, and probability of events, and all these details, and just even bias theorem, and joint probability, marginal probability. These details are briefly explained. If you need more, you can deep dive into any of these topics, but these are some of the key areas that you would need for machine learning. And descriptive statistics, when you are describing or summarizing your data, or in any case, you would need to understand what central the centrality or the central tendency values, like the arithmetic mean, the geometric mean, median, mode, range, quartiles, quantiles. All these details are very important. In addition to that, you would have to understand what standard deviation and variance or variability means, and then just how you can interpret variability. The other concept is correlation analysis, and just there comes Pearson's coefficient of correlation, and Spearman rank coefficient is another concept. So you see, so just in one page, a data science cheat sheet, so many things got touched. So just you go here, you are done. And for data cleaning, you can learn more. For feature engineering, you learn more. For statistical analysis, you have all these kinds of details that you can utilize. So these are a couple of data science related cheat sheets. All of these are related. And then like, in addition to that, now it starts talking about algorithms, right? The modeling taxonomy, modeling, the different modeling taxonomy. Here comes the different types of machine learning, like supervised versus unsupervised. A supervised models that feed input variables xi to a known output variable or labeled value. Unsupervised model that take input variables, but they don't have an associated output to supervise the training. The goal is understand relationships between the variables or observations. Black box versus descriptive. All these details are important. And in modeling evaluation, we have classification and regression. We said that the problem types are two: classification problem types and regression problem types. Corresponding to each these problem types, we have these details. And now, so this gives you a very good detail about short description about so many facts. Like now, it talked about algorithm, the different algorithms here, network, the nearest neighbor classification and clustering, and then it comes down to different types of machine learning, part one, part two, naive bias, ensemble, bagging, random forest, boosting. So these are different types of machine learning approach. So I'm not getting into the details of the things, but just roughly this summarizes some of the topics that we would be touching and deep diving into. So this gives you a summary of the details. So this is one of the cheat sheets, but the longest one, having 191. And just let me go roughly. So if you remember this, in my first presentation, I showed you this CRISP DM, the cross industry standard process for data mining. So this step is summarized as the business, understand the drivers, measure the drivers, uncover problem opportunities, and things like that. So from business perspective, now comes the data science with Python work, right? So the Python workflow, you can go to each of these, click each of these, and you will get the corresponding cheat sheet that is applicable to each of the areas. Or, and this is data science with R. R is a different programming language. You can skip it. I'm not expecting you to read through this 191 page cheat sheet. If you do, that's not a cheat sheet, the concept, the intention of the cheat sheet. But what you can just you can search for whatever cheat sheet that you want and go through your selected cheat sheet. For example, Jupyter Notebook. This is a cheat sheet for Jupyter Notebook. If you are using, we are using Jupyter Notebook, but when you are using Jupyter Notebook, these are the cheat sheets, the things that you should know to effectively work on the. So I have to rotate back, control plus shift plus minus. Then just this makes it larger. And this is a basic printing and getting help in Python basics. So these are the cheat sheet for Python. And it goes like a couple of pages here, right? Yeah, and plus, so this is importing data. So how can you import the data? First, importing data in Python. Most of the time, you will use NumPy and Pandas. You remember, this is the reason why we studied these two libraries. And then just NumPy info. So how you can get help, how you can work with plain text files. So this is how you would be reading plain text files, and it goes on like that. So this is one. And again, NumPy, specific to NumPy, you have this cheat sheet. This cheat sheet is specific to NumPy. If you remember, like just we discussed about, NumPy has a core library for scientific computing in Python, which provides a high performance multi-dimensional array object. And here we go. And the Python NumPy is kind of long. And now Pandas follows. The Pandas cheat sheet is here. Okay, enough of this. And again, the third important library which we discussed today is Matlab. Some of the things that you see in this cheat sheet are already covered, but to recall them, you can look into this. And Seaborn is another plotting library, just statistical data visualization library. So you could use this library, or probably you might notice us using this library somewhere in our code. Okay, so enough of the cheat sheet, this cheat sheet. The other cheat sheet is the Azure Machine Learning Algorithm cheat sheet. The Azure Machine Learning Algorithm cheat sheet. In this algorithm, in this cheat sheet, we will see. Okay, so this cheat sheet is created by Microsoft, and it gives you an idea about how you can select, how you can start with a problem. Remember, now you have a project team, and this project team, you chose a domain. For example, for one of the problems chosen by a group in Jima University is agriculture, and that's the domain, agriculture. And in agriculture, they are planning to choose a specific area. And in that specific area, since the domain by itself is big, and even the specific area may have different types of problems, you start with what you want to do. So this is where you start. So this is the the holy grail of machine learning. What are you planning to do? Just what is the problem at hand, and are you going to extract information from a text, right? So if so, just consider these algorithms. Okay, consider these algorithms. A text analysis approach, this area helps you drive high quality information from text. Then the specific algorithm would be latent dirichlet allocation, or extract n-gram features from text, or feature hashing, pre-processed text, word to vector. So these are the different, and each of them are provided with their corresponding description. For example, word to vector converts words to values for use in natural language processing tasks like recommenders, named entity recognition, machine translation. So these are the things that you can do if what you wanted to do was extract information from text. Another, if you want to predict values, remember, like just one of the two problem areas that we said in the cheat sheet, where one is classification, the other is regression. So regression has got multiple algorithms here. Oh, do you want to predict values? Okay, now regression is your area, and regression makes forecasts by estimating the relationship between values. So given two or more variables, and you choose one variable to define or to determine the other the value of another variable, which is a numeric value, then predicting values can be done by using regression. So it makes, and then just when it comes to predicting a distribution, then fast forest quantile regression, or Poisson regression, it predicts event counts, or linear regression, the fastest fast for training, and it creates a linear model if the relationship between the variables involved and the target output value is a linear relationship. Otherwise, you can use Bayesian linear regression, a linear model, but used for small data sets. And it gives you additional detail when and how you use. And decision forest regression. It basically accurate, it is accurate and fast training times. Or you may use neural network regression or boosted decision tree regression. So these are the different types of, the whole point of this cheat sheet is to help you understand how to deal with a problem at hand, how to deal with a problem at hand. Again, on the right side, let's do one more thing, and then we will go out of this. What do you want to do? Do you want to predict between two categories? For example, we wanted to identify if a given animal picture is a dog's or a cat's picture. That could be something, right? So we want to predict between two categories, a dog category or cat category. So this is a two-class classification, right? Between two. It could be you can have several categories. In that case, you go to here. If it is more than, let's say, like just t-shirt sizes. T-shirt sizes, not a numerical value size, but a categorical value size, like small, medium, large, extra large. These are 4 different t-shirt sizes. And given a t-shirt, if you want to classify the size of the t-shirt, then this is predict between several categories. So in that case, you can come multi-class classification. So a 2-class classification and multi-class classification. Or do we want to classify image just the way I said earlier, like just the image of a cat or the image of a dog? Although it is a 2-class classification, but since it is image classification, you come down to the image classification. And so this classifies image with popular networks. RaceNet or DenseNet are among the algorithms that you would use. So this and another thing is, like, just before I go, if what we want to do is doing prediction or identifying unusual occurrences, for example, fraud detection for bank transactions, then we can use anomaly detection. Anomaly detection identifies and predicts rare or unusual data points. Then you can utilize one class support vector machine, which supports under 100 features, aggressive boundary. 100 features means the number of variables that determine a data point, or PCA, principal component analysis based anomaly detection, which is fast training times. It also gives you the training time. Now, this is the second cheat sheet that you could use to basically map between your problem statement, what you want to do, and what kind of algorithm that you could use. So this is a very good one. And the third one is the ML supervised and unsupervised. Machine learning supervised and unsupervised. This cheat sheet mainly summarizes the top machine learning algorithms. So here we have the supervised, the unsupervised learning right here. And let me maximize. At the top, we have supervised machine learning. This is supervised machine learning. And just below, we would go to unsupervised machine learning. But among the supervised machine learning, we have tree-based models or linear models. This is wrong, not linear. This is regression models. All of them you see here are linear regression, logistic regression, bridge regression, and lasso regression. This is from Amazon. This is Amazon's way of providing details for you. Now, let's take one from each area. Linear regression. The description is a simple algorithm that models a linear relationship between inputs and a continuous numerical output variable. So this is a description. And how do we use linear regression? Its application or use case is stock price prediction. Can be done using linear regression. We are not. This is a simple list. It doesn't. I don't recommend using linear regression to predict stock, because predicting stock is a very complex problem. But it could do that. It could do that. And the other one is predicting housing price. Most of the time, housing prices get predicted using linear regression. At times, it may not perform well. In any case, it can be used. And predicting customer lifetime value. So based on one or more, two or more variables, you can predict customer lifetime value using a linear regression. And then just we have to use the corresponding algorithm to create the model. And the advantages are explainable method. Explainable method means you can tell the user of the model why the result came out the way the predicted value is the way it is. And interpretable results by its output coefficients. That's exactly explainability, and faster to train than other machine learning models. It is the simplest and fastest machine learning model. But the disadvantage is it assumes linearity between inputs and outputs. It is sensitive to outliers. If there are like just very small and or very large values within the data distribution, then the output, the model will be affected. And it can underfit with small high dimensional, can underfit with small high dimensional data. High dimensional data means if you have so many variables to represent a data point, then linear regression is not going to be a good model because it underfits. So this is one of them. So among the linear, the supervised models, and let me add one more from the supervised model, like for example, decision tree. Decision tree, the description is a decision tree models make decision rules on the feature to produce predictions. It can be used for classification or regression. Decision tree, it could be a classification or a regression. Regression classification is for discrete classes, but regression is for continuous values. And the use case is customer churn prediction or credit score modeling. It is very popular. Credit score is a very popular concept in the West, but I don't think there is one in Ethiopia. Or disease prediction. So in healthcare, decision tree can be used for disease prediction. And explainability, it's explainable and interpretable. You can say, because you can explain why the decision, why the value is classified to one class or the other class based on a graph. And we will see a practical example here. And the disadvantage is it's prone to overfitting. Overfitting is a concept. We will discuss about that. And sensitive to outliers. Outliers means when there are like just extremely high values in the data point or low values in the data point, the model gets affected. So this is a disadvantage. So the other list, the list in the bottom are unsupervised learning. From unsupervised learning, we have clustering and association. In clustering, we have three different types of clustering. One is k-means, the other is hierarchical clustering, and the third one is Gaussian mixture models. So So these are the three different types of clustering. Just the most common clustering is a k-means clustering algorithm, which is the most widely used clustering approach. It demonstrates or it determines k clusters based on Euclidean distances. Then the use cases, the description, the advantage and the disadvantage are written here. So all in all, these three, the first one, which is a 191 page, the second one, which is a 1 page, and the third one, which is a 1 page, are very important cheat sheets ወይም አጤሬራዎች ናቸው ማለት ነው. And you can use them to refer whenever you are in a state of confusion to recall what is what. Just you can open any of these cheat sheets. Mainly this cheat sheet has got so many things in it. I think this cheat sheet might already be included in the first one, but I know that this is very recent from Microsoft. The Microsoft one I don't think is included in the first. Maybe the third one, this one might have already been included in the third one. I haven't seen the details. In any case, do you have any question here? What is the difference between feature engineering and feature selection? Excellent. That's a very good question. Can we use both of them at the same time? Is feature selection conducted after or before model training? Can we use PCA to select features? Excellent. Very good question. Very good question. So feature engineering and feature selection are two concepts. Feature engineer. Let me say this. Feature selection and feature engineering can be used at the same time. It can be used at the same time, but the feature selection precedes. Feature selection means selecting what features are important for describing the problem area, or which features you can filter out features that are not such important. And in that case, whatever remaining features are features that you chose to keep in describing the problem or solving the problem. So the problem, the feature selection is selecting a certain number of features from all the features that you are within the data. Feature engineering is in case you need to re-represent or to normalize the existing features, you can introduce new features that those new features are called engineered features. Engineered, you are adding, you are using some sort of logic to create a new value, a new feature out of existing features. So this is what's called feature engineering. So feature selection is important and feature engineering is also important, but you may or may not need a feature engineering. But most of the time, feature selection is required, because everything in real world data gets collected for different reasons. But when that data comes for your machine learning process, you may not need all the features of that particular data. You may choose out of maybe 200 features of the data, you may choose only 20 of them. The remaining 80 may not be applicable for your problem solving process, so for your machine learning. So that's the difference between feature engineering and feature selection. In feature engineering, while feature selection is reducing the feature space to a selected important features. Feature engineering is adding additional feature which are created by you, and you could use both at the same time. And the other one is PCA, means principal component analysis. Principal component analysis is a way of feature selection. The principal component analysis, it analyzes which features are important. It reduces dimension, and then it helps you to select the best features. And the other question from this one is, I think this is asked by Sion. The other part of Sion's question is, can we use either feature engineering, feature selection before or after model training? Model training is the last step, but feature engineering and feature selection should happen be ahead of the model training, because just your ready data with the selected features and engineered features together are going to be supplied to your algorithm for model training. That doesn't mean that your model training is not going to be repeated. You may just a feature that you selected and new features that you engineered may be important for one algorithm, but if you are to train another algorithm on the same data, you would have to repeat the process. So there is an iterative process. Great. The other question here is, are the machine learning algorithms exhaustive in the cheat sheet, other clustering methods as dbScan etc? No, the cheat sheets are not exhaustive, but as I said initially, cheat sheets are a smaller portion of the key areas represented in brief descriptions. At error ብለን ያልነው, and just in your at error you don't include every detail of your note, right? Probably just you may ignore some of the important points from your at error because you don't consider them, or you know all of them. So just like that, the cheat sheets are not exhaustive. They don't include all the algorithms. There are, I believe, depending upon the area, you could have like 200-300 algorithms, and just none of, I think these algorithms are not even 20, the algorithms that we discussed. So they are not included. Any other question is, how can we process data and handle errors? Perfect. We are going to discuss more in detail about the machine learning process. The reason why we discussed like the first three classes up until now, we're focused on the first class was providing you a general overview of what machine learning is. The second class was explaining to you about an important library, which is NumPy. The third class was discussing about another important library, pandas. And the third class, the fourth class today, we covered MATLAB, and now we are kind of gearing towards discussing the details. So as of next class, we will be taking one problem at a time and discussing about the machine learning. So the data preparation and error handling will be done as we go along. And another question, what is the difference between feature engineering and feature extraction? I think I explained that. I suggest you go back and listen 1 minute from this 1 minute back from this explanation in the recording. Okay. On clustering, we can understand the relationship between the features. If they are related, they will more make good cluster. But what can we do beyond clustering? The time you apply PCA on large data, it will go blind. So how can we interpret it? Oh, definitely. The problem with unsupervised machine learning is you cannot interpret, you cannot explain. When you do PCA, basically just it will do dimension reduction, and you will lose the details, right? There is no going back. You will lose the details. The data gets represented, but represented in a proportional way. So if I understood your question, after PCA, how can we interpret? The interpretation is in research, not only for clustering, but also for most of the unsupervised machine learning, because we are trying to identify pattern. In case of PCA, we could say because of this and this fact, this data is reduced to this dimension, but we cannot explain that much. And can we use data which is labeled by unsupervised machine learning algorithm for classification, ML algorithm? Yes, definitely. This is one of the applications of unsupervised machine learning. Unsupervised machine learning sometimes used for data processing. For example, PCA, principal component analysis, is unsupervised machine learning. It basically reduces the dimension, and once you reduce the dimension, you may label, or you can let the algorithm to label your data. Then the principal component analysis will not give you the model, but it give you the data, which is in a way labeled that you can feed it into a machine learning, another supervised machine learning algorithm. Another example of a unsupervised machine learning is clustering. Clustering, you can classify, you can categorize or cluster a given data into certain clusters. And after looking at the relationship between the data within each clusters, you can label them. The clusters, you can label them, and that label can be used to train a classification algorithm, which is a supervised machine learning algorithm. So very, very good question. Adisu, very good question. Okay, a question from Talahun. What is the real difference between supervised machine learning and unsupervised machine learning? Here, painting for hiding relationship of the data. The main difference between supervised machine learning and unsupervised machine learning is supervised machine learning is a machine learning based on a labeled data, known label. For example, if you want to classify image classification, you would want to know what the images are originally labeled as before you start training. For example, you want to classify dogs, cats, and horses, 3 classes, and you could have like hundreds of thousands of images, and all these hundreds of thousands of images have to have one of the 3 labels. An image should be identified or labeled as a dog, or labeled as a cat, or labeled as a horse, unless and otherwise the image is labeled as one of these 3 categories or classes, then the image will be excluded. So all those images identified as either a dog, a cat, or a horse will be used for training a classification algorithm, image classification algorithm. So that image classification algorithm, the way you train the process is called supervised machine learning process, supervised, because all the images were classified as horse or cat or dog. So in case of unsupervised machine learning, your intention is not to classify or to identify something. Instead, to learn a pattern from the data. So unsupervised machine learning, the target is to generally observe the nature of the data and see what's wrong, what kind of pattern there is in the data. So that's the difference between. And in simple terms, supervised machine learning depends on a labeled data, just the way I said, as cat, horse, or dog. And on the other hand, the unsupervised machine learning does not have this kind of labeled data. The data is generally available for you, and you apply one or more unsupervised machine learning algorithms that don't require the data to be labeled for training. So this is the difference between the two. What dimension reduction would you suggest if the data is both categorical and continuous for clustering purpose? It depends on the type of clustering that you would use. So depending upon the, and also depending upon the library that you use for clustering. Some libraries don't mind using both categorical and numerical data for clustering because they will internally convert the categorical to numerical data. Since clustering is dependent on distance calculation, the simplest algorithms would require the data to be converted to numerical. But other, for example, Spark machine learning algorithm may not. I think just Spark machine learning algorithm needs the data to be converted to numerically. But the dimensionality reduction, yeah, it depends on the type of problem that you have at hand. How many minimum types of attributes must we use to do classification on one data set into two categorical? I don't think that's it depends. You can have like 40 50 or 100 data points, but just that doesn't mean that you're so what's important to understand about your data is your data, I mean, your model and your data relationship. The world of your model is your data. The real world of the model is the data. It's only the data. And if you want the real world of your model to be bigger, you need to have as much data as possible. Otherwise, the performance or the power of the model is limited by the size of the data that you have at hand. So the smaller the data you have, you can train a model, but the applicability of that model would be limited only to the data in that particular range. So that's an important aspect that you should be noting. Okay, I think we have most of the questions addressed. And now, before I close the class, let me take you back to what we covered today. What we did today was, like, I summarized the MATLAB library here, library here, and this Jupyter notebook is located in my shared drive. The Jupyter notebook is in the notes. Here it is. You can copy. You can get it and have your own Google Collaborator and run it just like this, and that's it. And the cheat sheets that I explained, the 3 cheat sheets that I explained today, are here. The supervised and unsupervised is Amazon cheat sheet. The ML and data science lifecycle is a collected cheat sheet by someone, and the Azure machine learning algorithm cheat sheet is a Microsoft cheat sheet. So these are the things that I would like you to take from today. And one note, I will send the links of where each of these are, along with the recording of today's class. Okay. Anything else? I think this is a long class, and thank you so much for your time, and appreciate your patience. Today it looks like just we have consistent attendance. And I think, and one note, sorry, one note that I would like to remind you is very few of you said you are interested to participate in the project, and I received like 3 or 4 groups only from two universities. From the rest, I haven't. So I strongly suggest you grouping yourself so that you can have a real experience from the course. I can lift the deadline. The deadline was today. I can lift the deadline if there are interested folks. You can send me up to Wednesday. Choose a domain, choose a specific area. Remember, I sent out the project detail last week, the project description, and I explained what the areas are. And the content is here in under course outline. No, not course outline. Where did I put the project? Yeah, the email project detail. It is here. The email project outline and instruction is explained last week. So if you didn't get a chance to see this, please go through the project outline, the instruction details, and create a team and send me until Wednesday. Yeah. Okay, thank you so much for your time. With this, we can conclude today's class. Thank you. Have a nice day.